if you've ever copied a pip install command without really knowing what it changed. This tutorial is for you. Python programs often rely on reusable packages that add powerful features without forcing us to build everything ourselves. Pip is the tool that installs, upgrades, inspects, and removes those packages. In the next few minutes, I'll show you the pip commands you'll actually use safely inside a virtual environment. A Python package is reusable code created to handle a particular task. A package might help your program make web requests, work with dates, add color to terminal output, connect to a database, build a Django website, or do thousands of other things. Pip is Python's standard tool for installing and managing these packages. Most packages are found on PyPi, sometimes pronounced PyPi. The Python package index is a vast public repository containing packages created by the Python community. When we run pip install, pip finds the requested package on PyPi, determines whether it needs any additional packages called dependencies, downloads everything required, and installs it into our active virtual environment. Our Python project can then import and use those packages. A wheel is a ready-to-install Python package file with a name ending in .whl. Pip normally downloads wheel files automatically from PyPi, so you may use them without ever seeing them. Some projects and software vendors also distribute wheels through trusted websites, release pages, private package repositories, or Git repositories. A wheel's file name normally includes the package name, version, and compatibility information for Python and the operating system. Leave that file name unchanged. To install a downloaded wheel, use the same pip install command followed by the wheel's file name. Only install wheels obtained from a source you trust. Later in this tutorial, we'll install one from a local file. Let's walk through a quick demonstration to see how this works in a real Python project. We'll begin by creating a virtual environment named .venv. This is where pip will install the packages used by our demonstration project. The second command activates that environment. Creating, activating, and managing virtual environments is covered fully in my separate venv tutorial, so we'll move through these two commands quickly. Now we'll ask pip for its version. Notice that the displayed location points inside our .venv directory. That confirms we are using the copy of pip belonging to this environment. The fully explicit command is python-mpip. Because our virtual environment is active, its pip command is already first in our path. We'll use the shorter pip command throughout this demonstration. Pip is itself a Python package, and the copy included with the new virtual environment may not be the latest version. This command tells pip to upgrade itself. Because our virtual environment is active, it updates only the copy of pip installed inside .venv. It does not upgrade the system copy of Python, and it does not upgrade every other package in the environment. We are simply making sure that this virtual environment has the latest available version of pip before installing anything else. A requirements.txt file is a plain text list of the packages needed by a Python project. It allows someone else or you on another computer to recreate the project's working environment. You will often find this file included when you clone a Python project from a GitHub or GitLab repository. Let's take a quick look at this file. The requests package does not specify a version, so pip will select the latest compatible release. Colorama is pinned to the older version 0.4.5, which will give us something to upgrade later. Packaging represents a dependency that we may or may not need for this project. To install all of the packages in the file we run, pip install -r requirements.txt. The -r option tells pip to read its package requirements from this file. Pip then installs every listed package, along with any additional dependencies those packages require. Let's see what pip installed in our virtual environment. The pip list command displays every installed package and its version. This includes the packages named in requirements.txt, as well as the additional dependencies that pip installed for them. When we want more information about one particular package, we can use pip show followed by its name. Pip show Colorama displays the package name, its installed version, a brief description, and its installation location inside our virtual environment. It also shows which other packages it requires and which installed packages depend on it, when applicable. Looking at our environment, we realize that this project also needs the humanize package. The normal pattern for installing one package is pip install followed by the package name. Pip will find the latest compatible version in the repository, download it, install any dependencies it requires, and add everything to our active virtual environment. Humanize is a small commonly used package that converts values into more natural, human-readable text. After the installation finishes, we'll use pip show humanize to confirm its version, view its package information, and verify where it was installed. Packages receive updates over time. So pip can help us identify the ones that are out of date. The pip list outdated command compares the packages installed in our environment with the versions currently available from the package index. Here we can see that Colorama version 0.4.5 has a newer release available. To upgrade it, we use pip install with the upgrade option. This tells pip not to leave the existing version in place. Pip downloads the latest compatible release and replaces the older version. The same command pattern can be used to upgrade nearly any installed package. We discover that this project does not actually use package, so there is no reason to keep it installed. The normal removal pattern is pip uninstall followed by the package name. Before deleting anything, pip displays the package it plans to remove and asks us to confirm the operation. We'll type Y and press enter. Pip then removes the package and its installed files from our active virtual environment. Keeping unnecessary packages out of an environment makes its purpose clearer and reduces the number of dependencies we need to maintain. Before recording, I downloaded this pyfiglet wheel file and placed it in our demonstration directory. The / at the beginning of the file name tells pip that we are installing from a local file in the current directory, rather than asking it to search the package index. The installation command works the same way whether a trusted wheel came from a project website, a release page, a private repository, or a download page. Pip reads the compatibility tags contained in the wheel's file name, verifies that the package is suitable for our Python environment, and installs it into the active virtual environment. Wheel file names should normally be left unchanged because the version and compatibility information in the name is meaningful to pip. Our original requirements file no longer describes this environment accurately. We installed Humanize and pyfiglet, upgraded Colorama, and removed packaging. We'll rename the original file requirements.old so that we can keep it for reference. Next, pip freeze prints the environment's installed packages and exact versions in requirements file format. The greater than symbol is shell redirection. It takes that output and writes it into a new requirements.txt file. When we display the file, we can see the packages we installed directly, along with the dependencies pip installed for them. Pip freeze records what is currently installed. It does not perform a new dependency calculation or decide which packages the project actually uses. Finally, pip check verifies that the installed packages have compatible dependencies. No broken requirements found confirms that our environment is consistent. Let's finish with 4 practical rules that will keep pip predictable and your Python installation healthy. First, activate the project's virtual environment before installing anything. Second, use pip only after confirming that the virtual environment is active. This keeps the packages isolated from your system Python and from other projects. Third, record the environment's dependencies in a requirements file so that the environment can be recreated later. Finally, do not use sudo pip install. Giving pip administrative access can overwrite system-managed Python packages and cause difficult conflicts. A virtual environment gives pip everything it needs without requiring elevated privileges. Here are the essential pip commands we used in this tutorial. Pip version identifies the active copy of pip. Pip install adds a package. Pip install upgrade updates an installed package. Pip list shows everything installed in the environment. Pip show displays detailed information about one package. Pip freeze records the installed package versions in requirements.txt. Pip install -r restores the packages listed in that file. And pip uninstall removes a package we no longer need. You can pause the video here or capture this screen to keep the commands as a quick reference. And that's it. You now know how to install, inspect, upgrade, remove, restore, and record Python packages with pip. If you'd like a deeper explanation of virtual environments and why they keep Python projects isolated, watch my Python Venv tutorial next. If this video helped you, please click like and subscribe to Kendall's Tech Tutorials for more practical Python, Linux, Django, and open source tutorials. Thanks for watching, and I'll see you in the next one.